In this particular session of the video, we are going to work with our first ever machine learning model, which is going to be called out of the linear regression model. Up to this particular point, what we have been doing actually is actually to pre-process our data to understand what our data is actually doing by making that of standard, scalar, memas, encoding, and a whole lot of stuff. And our previous video, we were able to look at this train test split, what actually these train test split actually do. So this particular session of this video, what we are basically going to do, we are going to make use of that of the linear regression from linear regression to actually solve some machine learning problem. So what is actually this linear regression that we are going to make use of? Linear regression is a type of algorithm, is a mathematical formula that tries to find a pattern or a similarity of data by maybe the data you're actually giving, and then the new output the new input that you give it from the what it have learned from your previous data, then you can actually try to make prediction. It's actually all these guys are basically the mathematical formulas. So in case if you're wondering what they are just mathematical formulas that actually can help you to predict the next the next output. So that is just basically the word. But this linear regression focuses on those of the linear problem. When I mean linear problem, they are not that type of discrete. Okay, like when we look at this kind of problem, looking at salary, this 5,000, this is not actually discrete. But an example of discrete is that this of 1 and 0. Their target is more like discrete, can be that of maybe two, maybe yes or no, or maybe yes male or female. Just maybe it has that type of discrete discrete values. But when it comes to that of the regression problem, they are continuous, meaning that this can be maybe 5,000 point, maybe 9 or so. So these are all linear regression problems. So don't mistake linear regression for a classification problem. It doesn't mean you can actually use linear models to sort out of the classification, but it doesn't mean they can use that of the classification models to actually solve that of the linear problem. But the reason that make use of linear problem for linear problem, classification problem for a classification problem, is to avoid that of the overfitting and underfitting, which was basically going to learn as we go on. So by the end of this video, we're definitely going to have that knowledge or full knowledge on that of the linear regression, on how to make use linear regression, how to implement it, and how to actually make use of it to actually do prediction. So this particular session, remember, we're basically going to make use of our pen and paper to actually solve this problem. So let me just comment this what we did in our previous video. Let me just comment it out. So down here we are going to basically present the data we are basically going to use. So this is data, I just have copied it and I just pasted it. So this is data we are going to use, work TA, and that of the salary that we are going to actually predict. So our input futures I can say our X is going to be this of the work TA, and then we are trying to predict this of the salary. So that's basically what we are going to do. So I'm basically going to use this my book, but this is my paper I'm going to use to actually solve this kind of problem. So we can actually get to understand it really well. So if you enjoyed the video, by the end, make sure to actually subscribe and like. So let me just drop this guy. It's useless. Actually solve that for that of linear regression problem, since it's one of the most basic machine learning model out there that we can make use of to solve that of the linear regression problem. Now our screen earlier, we saw we were given a task to actually find the linear relationship from that of the how old or how long has somebody worked in a particular company, and the salary there were the salary that the person was actually given. When we look at it, we saw that how long have you been worked. They say we were told I worked underscore years, and we were given the values to be 1, 2, 3, and they'll have 4 and then 5. We'll just use this sample to actually look at our data, not actually to go much in depth. And we're giving for the work tier. The next one we're actually giving is the salary that each person that worked for this amount of year is being paid. So the first amount of salary we're given is that of the 30,000, and followed by that of the 35, and followed by that of the 40, and then followed by that of the 45, and then lastly that was 50. Remember that the reason I put this comma so we can easy for us to actually tend to understand this type of values. Remember that these commas here, they differentiate each other, so you don't get confused. So remember that if you worked for a year, you're approximately going to be paid 30,000. If you have worked for 2 years, or I can say 2 years of experience, definitely your salary had to be more compared to that of somebody that just worked for a year. So and that we can use linear regression to actually solve this kind of problem. But if we want to make use of pandas to actually structure our data to actually look pretty much, so we can assign this our worked year, because that is actually our independent feature that we're going to set to actually get our target. Remember that this is our what? This is our target that we're trying to get, and this is the what? Independent these are independent variables, or you can say feature. The reason why they're independent is because they don't actually, is with the help of these variables here that I can say the features here, that is actually we can use to map out to that of our target, which is our, and we can, most of the time we assign it a variable of y. So if we assign this work here to be our x, and then our salary, which is our target, because when we are looking at target, we are looking at what we're actually trying to predict, the result that we actually want, by making use of, or can say, other independent stuffs that happen, like other independence. What we mean by independent variable are things that can lead to a particular event to happen. So that is just basically what independent variables are. So, and the target is salary, so we can try to give our salary x, sorry, our y, sorry, not x, and then work here to be x. So we can actually maybe draw a kind of table to actually make it look a little bit better. So here is going to be our x, instead of writing the work here. So we are going to have 1, 2, 3, 4, and then that of 5. So for our first year, we know that that is going to be 30,000, and second year is going to be 35, third year is going to be 40, and then fourth year is going to be 45, and the fifth year is going to be 50. Remember that this is just a basically simple data. Remember that this is going to be our y. So since we have now assigned our worked and our salary to be that of the x and y, so we won't get confusing. So now we are going to introduce our the linear regression formula, which is given as that of the y equals to mx plus c. When we look at this y, we have already explained what y is. When we look at it, and then this is, remember what we wrote here is our target. So this is our target. This is our target, and then we know that y m we haven't seen, m is actually called that of the midpoint, and for x we have actually looked at our x is that of the independent can say variables or things that can actually lead for that event to actually happen, or I can actually call them features, and our c is that of the intercept of the line. This is just basically it. Then we can actually call this of our m is actually, you can actually call it that of the coefficient, or you can call it or slope. The reason why we actually give it this coefficient or slope, the reason why it's actually like this, because coefficient and slope, these are the changes in this of the m. The m is like more of the driver of this of the equation that we have here. The more the this midpoint actually try to tell us that the more how the x changes determine how the y changes. So why this c just trying to tell us that the value of y when the x is equals to 0. So this is more like the initial, the value of this of the y when the x is equals to 0. This is just more like the initial. But this, the main driver of this this formula is this of the coefficient, or you can call it that of the slope or the midpoint. So if this values changes, it will affect the s. Automatically is going to affect the y. So since we have known what y is our target, then we need to find x is the next features that we are going to use to actually get this of our y, and then what is remaining for us is to find this of the c and this of the m. And to find this of the m is basically simple. So to find m is basically that of the n times that of the summation of our xy in bracket. We are going to minus with that of the summation of the x times that of the summation of the y, and then we're all going to divide it by what? By our n times the summation of that of the x square, and then we're going to minus it from the summation of x square. This is the formula that we can use to find out of the coefficient or the slope or the midpoint of this of our linear regression formula here. And so for us to get our c is basically that of the y bar minus m times that of the x bar. So you'll be wondering what this of our y bar and what is our and this of our s bar. So for our y bar that we can see here is basically that of the summation of our y divided by that of the n, and for our x bar is basically that of the summation of our x divided by n. So what is this of our n? This n, okay, let me write it down here. This n is basically can say total number of elements. When I mean total number, you can think of it as the total row of row of data that we have, because when we count here 1, 2, 3, 4, 5, the element that appear, or I can say the row of element that appear on our data is actually that of the 5. So we can set our n to be what? 5. Or you can also look at it as number of observation, number of elements observed, which you can get our n to be 5. What you have to do is just count the number of elements that exist, or maybe on that of the x and y, because definitely they are going to be the same, even though there are unknown values on them. Just count them, they're basically going to be the same. You have 1, 2, 3, 4, 5. So that's where we got this our n to 5. So this is basically every formula that we need to actually solve our linear regression problem. So what we're basically going to do next is actually to get our summation. This is actually supposed to be summation. We know what summation is. Summation is more like summation as the total sum of a set of elements. So that's basically what summation is. Let's say in a situation whereby I have something like let's say we have something like 1, 2, 3, and then you have to say the summation. Let's say this is actually given as e, and the summation of e is actually that of 1 plus 2 plus 3. This is actually 5. Yeah, that's actually 5. Then it's going to be 6. Simple as that. So that's actually what summation is. So we're going to, since we have given our x and our y, so we're going to do some other mathematical things on it. So let me actually bring out a new sheet so we can actually do it here. So let me just cover this. So the first thing that I want to actually do for this of our x, and then we're going to put down our y. So I've been given the value of our x, which is 1, 2, 3, 4, 5, as we can see here already. So I just want to write it down. So I have the value of y to be 30,000, and then I'll have the second one to be 35,000, the third one to be 40,000, fourth one to be 45,000, and then the fifth one to be 50,000. Actually drawn out these parameters were actually given. The first step, since we know our n, so we need to find this of the summation of the xy. So before you can find the summation of xy, you need to actually do for this of the xy. So it's going to be x, y. Simple as that. I know what xy is, just 1 times 30 2 times, because this is value of x, each of them, because it's as if we're trying to loop each of the value, get the each of the value. So first one is going to be this 1 times this of our 30 that we have here, 30,000, followed by this of our 2 times 35,000 that we have here. Then third one is going to be 3 times our 40. So we have that of the 40,000 that we have here, and the next one is 45 times 45, which is 45,000 that we have here, and then 5 times what, 50,000. So definitely, why, if we are going to sum all these guys together, so on our equation again, on our equation, so we are going to also find that of the, this is the xy, so we are also going to do the summation x, we're also going to do the summation y, y, we're also going to do that of the summation, and then we have this of the x square summation, so we're also going to do for that of the x square. So after that of the x square, then we're going to square the summation of this of the x. So let's do for this of the x square. So we know that the first one is 1 square, then 2 square, that's third one 3 square. Remember that this 1 2 3 are just basically, remember that this is x, so we're referring to these two guys are the main guys that we can see here. So the fourth one is that of the fourth square, and the fifth one is that of the fifth square. So we know this one is 25, 16, 9, 4. Okay, let's just do this. 1 square, so 1, this is 4, this is 6, sorry, that should be 9, sorry, not 6, and this is 16, and this is that of the 25. So if we are to do this with our calculator that we have here, okay, so if I do this, so for the summation of this of the x, so let's just put summation here. So now we are going to sum everything that is here to get our answer down here. So if we are to do the, for this of the 1 plus 2 plus 3 plus 4 and that of the plus 5, we'll be having here to be that of the 15. So we now have the summation of our x is equals to 15. So I've actually gotten for this. And so for the summation of y, we had that of the 30,000 plus 35,000 plus, when you sum everything, this should give you 200,000. So we have the summation of our y is now what, 200,000. So the next one is summation of our xy. The summation of our xy is basically 1 times 30, we know is 30,000, and then plus, you can say 2 times sorry, this 2 times 35,000. So when you times all this, you sum all of them. 2 times 35,000, that is basically 70,000. So it's going to be 70,000 plus 30,000, which is the first element. So I'm just trying to times all these guys, times all of them. Then the answer, I'm going to add all of them together. But when you do that, that should give you 650,000. And for this of the, if you add all these ones, 1 plus 4, that is 5. Down plus 4, that is 5 plus 9, that is 16. 16 plus 16, that is 32. 32 plus that of the 25, that should, hope that's correct if I did the math correctly. So it's supposed to be 1 plus 4 3 square, that should be 9. It's going to be 1 plus 4 plus 9, okay, that is 14. 14 plus 16 plus 25, so that's supposed to be 55, not actually 57, that's 55. If you add all these guys, that should give you 55. So summation of our x square is what, 55. You can see how simple this is. And then the other one we have here was summation of x squared, then summation of x squared. So this is it, summation of our x squared. This is just like saying our summation of our x is 15. This is just like saying 15 squared. So when we do for that of the 15 squared, we should be having 225. So we'll have 225. So since we have everything checked right now, so we can then find our then we can now find our m. To find our m is basically simple. So we are going to put our m. Remember, we are trying to find the m. We know that by make use of the formula that's here. So we know that our n. Remember that our n is equals to 5. So it's going to be 5 times our summation of x, y, which is, this is our, okay, so this is, where is our x, y? So we didn't write it down. So this is the summation of x, y, which is our 650, because this is it in this particular section. So it's going to be our 650,000. Remember that we are following this formula. So minus, so remember, let's put this in braces. So this is summation of our x, which is 15, times summation of our y, which is 200,000. So then we are going to divide all of them by that of the n, which is our 5, times summation of x squared. This summation of x squared, which is 55, minus this is a summation of x squared, which is in our case 225. So with this, I've actually written down our parameters. So we're going to find our m. We know that 5 times 650 should be, you know that 5 times 650,000, that should be 3, 250,000, a million. And then we'll have the 15 times this of the 200,000, 1, 2, 3. That should give us 3 million. 1, 2, 3, 1, 2, 3. So we'll have this. And then the next one that we have is 5 times 55. When we do our 5 times 55, we'll have the 275 minus 225. So with this, we can actually say that our 3,250,000 minus of our 3 million, that should be that 1, 2, 3. This should give us 250,000. If you do this correctly with your calculator, so and then divided by, we'll have the 275 minus 225, but we'll get 50. So when you divide this properly, we can say that our 250,000 divided by 50 should basically give us 5,000 if you do that correctly. So now we can say that our m is 5,000. So then now we can head over to actually calculate for our, because when we look at our formula, we still have some other things that we need to actually calculate for this of the, we need to find our c, and to find our c, we need to make use of this y bar and this of the x bar. So we can basically do that. So to do that, let's do that somewhere here. So to get our c, we know that our c is basically y bar minus m times s bar, and our y bar is just basically that of the summation of y and that of the n. I'll know that summation of our y down here, which we can see here, that is actually 200,000 divided by 5. If we are to do that with our calculator, we have the 200,000 divided by 5, which should be giving us around 40,000. We have the 40,000, and for that of the s bar, you can, that's the summation of x divided by that of the n, and our summation of x here is what, 15 divided by 5, which if we do 15 divided by 5, 15 divided by 5, that should give us 3. So with this, we can say that our c is what, we know our y bar, which is 40,000 minus our m. We have gotten our m to be that of the 5,000 times this of the x bar, because this is the formula that we have here. This is 3,000, so not 3,000. So if we can do our 5,000 times that of the 3, we are getting what, 15,000 40,000. So we can say this is C equals to 40,000 minus 15,000. So we say our 40,000, which is our 40,000 minus our what? 15,000. We should be getting what? 25. Hope that's correct. That is 25,000. So this shows that our C is what? 25,000. Simple as this. So we have gotten our C, we have gotten our M. So let's head over back to our initial, you can say our initial starting point. So since we have gotten our M to be what? 5,000, and then we got our C to be what? 25,000. So these two guys is what we actually need, which is that of the, you know that our M is that of the coefficient, C is that of the intercept. So we can actually use, since we have gotten these two guys, we can actually make predictions with this. So this is everything that we need. We don't need any other thing. So let's assume that, know that we stopped in that of the 5 phases. Let's make use of this to make prediction, real life prediction. We're not talking about visual prediction, we're making a real life prediction. Let's say somebody actually worked in a particular company by making use of this data, worked for 6 years. Know that our X, now what we are going to do, our X is now going to be 6 years, right? So we are going to find our Y. So remember that this is now the new feature that we set in. I said the independent variable that we set in. So by making use of our formula, which is the Y, then by making use of M, our M, remember that this is our formula, which is plus C. So we can say our Y is this of the 5,000 times what? This is asterisk X. Our X is what? 6 plus what? Our C is what? 25,000. 25,000. So we can actually do this. So we can say our 5,000 times what? 6 is what? That is 30,000. So we have the 30,000 plus 25,000. So which is a plus 25,000. So we'll have that of the 55,000. So if somebody had that of the 6 years, can say worked for 6 years, so the expected salary of that of the person is actually that of the 55,000. So we can see we're able to implement this linear regression, because linear regression is a little bit, the math behind linear regression is not really much. I remember for linear regression to actually fit well in your data, your data must be a linear graph. This is what I mean. It must be a linear graph. Like when we look at this of our worked year, and this of the, we look at this of our worked year here, and this of the salary that we have here, which is this worked year, and this of the salary. When we look at it, let's assume we know that our worked is that of the X, so it's to be down here 1, 2, 3, 4, 5, and then the salary is let's assume, let's just, you know that everything is done is that of the 30,000. So we're going to just make it 30. You can say 35, yes, 40, 45, and here is 50. You see that when we look at it, this is going to be the when y, remember that this is y axis and this is the x axis. So when our x was 1, our y was 30, so it's going to be somewhere here. And when our x was 2, our y was what? 35, so which is given here. So same thing go for this of the 40, the same thing go for this of the 45, and the same thing go for this of our 50. You see that this is a linear graph that way, that I can see. You can also draw the same thing. You can see in case of 60, and then we predicted that if you work for 6 years, for the 6th year, if it was 6, and then we predicted that the salary will be that of the 55, which will be somewhere around here. You can see that this still follows the linear pattern, but in a case whereby your data is not actually fully linear regression can actually tend to solve that type of data, but that type of data for linear regression can be a little bit noisy, and at times it's not actually advisable for that. So that's when things like logistic regression, decision tree regressor, those big guys tend to make use of it. But let's say in a situation whereby your data is purely linear, or almost close to being purely linear. We can make use of linear regression to actually solve this kind of problem. You can see how this type of how we're able to solve this kind of problem. So this um actually actually try to tell us something that SK-Learn tend to make things a little bit easier rather than just doing. Just imagine to solve this kind of small problem, I have to go through this entire sheet of paper just to find the intercept and that of the coefficient, just to find. I have to actually solve all these things. Let's say I want to solve another problem, I have to actually start again to write all these things. You can see that this is actually less efficient, but just that in case if you want to actually understand the logic behind machine learning, so this is actually you can make use of pen and paper to actually grab it and actually tend to understand how it actually works. So that is just basically, but for a professional purpose, it's software or models tend to make things easier for you. Scaling, what scaling actually had, it was this formula, this formula, this formula, this formula, and then when you give it a data, it automatically insert all this formula, and then if you put six, like when you put six to be x to be six, it's going to give you this outcome. So that's just how machine learning models actually work. That, like I said, they are all mathematical formulas. There's nothing. If you know the math, you can actually create your own. If you know the formula, you can actually create your own, maybe create your own functions or classes that can actually take this input, maybe your x and y input right here, and then we can actually create this by just making use of len x. We know that len x is going to give us 5, so we have gotten our n. So x and y, we're going to times x and y. Pandas can actually make use of, we can actually make use of pandas to actually make this, to solve this kind of problem manually if we don't want to rely on that of scaling. But best advice, make sure to stick with scaling, because this guy can be really, really tiring at times. Even though you can solve it manually, it's not actually worth the stress. So we can see that this is how basically you can actually solve that of the linear regression. Okay, let me just try somewhere here. Linear regression, and so this is linear regression. So we just solve the linear regression problem. So we just solve a linear regression problem. So as we go on, we're still going to solve for that of logistic regression, that of decision tree. We're still going to make use of pen and paper to actually solve some of them, not actually all of them, because decision tree can be a little bit complex, but we're going to try our best. The random forest, that is not even anywhere go away, but we're still going to do a whole lot of touches on them to actually see how we can actually understand this a little bit more. So I think this is actually conclusive for solving our linear problem. So in case if you actually want to make another predictions, let's say you want to actually predict for the next 10 years. So we know that, let's actually write somewhere. We know that x, let's say x is not going to be 10. So we want to predict for the next 10 years. So then we will not want to, then we're going to set our y. So we know that our formula here, we know that we have gotten our m and that of our c. So our m is what? Remember that this is the formula for it. Sorry, set our y. So our m is what? 5,000. We're going to times it by our x. Our m is going to be times 10 plus what? 25,000. So we're going to have our y to be what? So let's actually 5,000. We're going to say times 10, which will be the 50,000 plus that of the 25,000. So no is going to be what? 75,000. So if you worked for 10 years, you expected to be earning 75,000. That is what our model predicts. So, but let's actually try to predict this of our trade. Let's actually know whether this actually work on the. Let's say let's try to play with our model. So let's actually give it our x. I want to set our x to be 3 years. Let's say work in 3 years. We know that is to be give us output of 40,000. Let's actually see that. So it's going to be our m, which is 5,000. 5,000 times what? 3 plus 2, 25,000. So this is going to be 5,000 times what? So 0 times 3, which is 15,000. I'm going to plus with 25,000. So it's giving us what? Our y is equals to what? 40,000. So if our x is 3, or S is 3 our Y should be 40,000. You can see our model is actually performing really well. So there are many other ways to actually know how well your model is performing by that of the R square score, by that of the mean square error, and also that of the mean absolute error. These three guys are one of the best way to actually know how well your model is performing, that of the linear, you can see, that of the regression models. So these three guys are mainly being used, that of the R2 score, that of the mean absolute error, and that of the mean squared error. So I think this is where we're going to conclude for this video. If you find this video anywhere useful, subscribe is going to be a problem. So I'll be happy to see you in the next one. Thank you.